So we talk about the hypothesis testing, and we said we just test a conjecture using the hypothesis test using H0 mu is equal to, for example, in the previous example, mu is equal to 70 versus mu is not equal to 70, right? By just using X bar. So X bar, remember X bar is a statistic. So we just test the hypothesis using the statistic. Hence, this is what we call a test statistic, okay? We just test our hypothesis using this statistic. How? By assuming that null hypothesis is true, we were able to plot the distribution of X bar, right? We were able to plot the distribution of X bar. Hence, we just plot it. And then we just find the critical region, which are the extreme values of the X bar by using the significance level alpha, right? Alpha. And after we just plot this, we just put the observed value of X bar. In our case, it was X bar was 71.8. We just put it in the plot to see whether it's in the critical region or not. If it is in the critical region, we reject the hypothesis. If it is not in the critical region, then we don't reject the hypothesis. So every time for different mu and for different sigma, we have a different distribution for X bar, right? Hence, it is important to plot it, then just finding the critical values B and then critical value A, then putting X bar and so on and so forth. So another way is, instead of choosing X bar as our test statistic, we just use not X bar, but we just use the Z as our test statistic, okay? How? Remember, we can just convert any normal random variable using the transformation. So X bar is a normal random variable. So what we do is we just subtract its mean and divide it by its standard deviation. Remember, so this is the standard deviation of X bar, sigma divided by root n, okay? And this is the mu of X bar. So X bar minus mu divided by sigma divided by root n, that's a standard normal random variable, okay? Now, since this is my test statistic, I will plot the distribution of this, okay? Not the distribution of X bar. So if you just use the X bar as your test statistic, then you just plot the distribution of X bar. If you use Z as your test statistic, then you just plot the distribution of Z, okay? So given that alpha is equal to 0.05, just plot your distribution of test statistic, which is Z now, and then find the critical region. What is your critical region? Well, just find the Z value, which leaves an area of what? Alpha over 2, which is 0.025 now, right? Because alpha is 0.05. And here, let me just plot it like this, and find the value which is alpha over 2 that's equal to 0.025, okay? And remember, what do we call this value? Leaves an area of 0.025 to the right. So this is Z sub 0.025. And this is the Z value that leaves an area of 0.025 to the left. Since these are symmetric, this is minus Z 0.025, okay? And Z sub 0.25, that's equal to 1.2096. So this is equal to minus 1.96, okay? And this is equal to 1.96. Well, that's great, because now this is simply my critical region, right? So to the right of 1.96 and to the left of minus 1.96 is my critical region. Okay, so my critical region, I can just write it, the real numbers minus 1.96 comma 1.96. This is my critical region. Okay, now what we should do is just find the observed Z. How to find the observed Z? Now remember, in the previous example, our observed x bar was x bar observed is equal to 71.8. So what we will do is simply just convert this to a standard normal, which is now our z observed, okay? So z observed is equal to x bar observed minus mu of x bar divided by sigma of x bar, which is equal to 71.8, our observed x bar, minus mu of x bar, which is 70, where, recall that this is from where? This is from the H0, okay? It comes from the null hypothesis. Divided by sigma divided by root 10, which is, remember, that's 8.9 divided by square root of 100, right? And this is equal to, I don't know the answer, but probably we have it in the slides. So this is equal to, let's see, 2.022. Okay, this is equal to 2.022. Okay, let me just change my color. See this z. So this is z observed. Z observed is equal to 2.022. Okay, so let me just sorry, let me just open another. Okay, let me just draw it here in a blank page. So this is okay. So I have this is 0.025, 0.025, and this is z sub 0.025. 1.96, but my observed value is, okay, my observed value is where? That's somewhere here, okay? So this is what? This is z observed, which is equal to 2.022, okay? Since it's in the, so z observed is in the, where? Is in the critical region. Hence, what you do is, hence you just reject H0, okay? Reject H0 in the favor of H1 at significance level of alpha is equal to 0.05. So what you do is you just reject the hypothesis at significance level of 0.05. Okay? It was the case in the previous example as well. So if you just make the same test using the X bar, remember, there you can see that we just had the same result. So if you just reject, so let me just write here, if you just reject the hypothesis using, if just reject using X bar, then you will reject, okay, then you will reject using what? Reject using z as well, because they will give exactly the same answer, okay? No matter you just use x bar or z, you will have the same answer. Okay. So, well, in fact, I just summary the hypothesis testing in a 5-step procedure, okay? 5-step procedure. So this is much more easier to just keep you in your mind, okay? 5-step procedure, 5-step procedure. Okay. How? First, just state your null and alternative hypothesis, okay? Just state your null and alternative hypothesis. So let me just open the whiteboard if I have. So, okay. So remember our question, I have n, sorry. So I have n is equal to 100. I just see that x bar is equal to 71.8. And I'm just testing what? Whether mu is equal to 70 or not. And I'm just given sigma is equal to, remember, 8.9. Okay, so these are the data that are given in the question. So just go back to the question. Now, just try to write the question in 5-step procedure. Okay. So okay, let me just write it like this. So let's take this. I will just give me a second. Okay. I will just write it here. X bar. So sigma is equal to 8.9, right? And I'm just testing whether mu is equal to 70 or not. Okay, that's great. So, okay, now we will just start with step 1. Okay, step 1. And let's use X bar here, and we will just use Z here. Okay, so let me just um, divide it like this. So this is my step 1, X bar and Z. Okay, now, and please just take alpha is equal to 0.05, okay, as significance value, which means I will just use 0 alpha over 2, which is Z sub 0.025, which is also equal to 1.96, okay? Now, step 1, just look at step 1. State the null and the alternative hypothesis. So I'm just testing whether step 1, H0 mu is equal to 70 versus H1 mu is not equal to 70, okay? So if you just use Z as your test statistic, well, the hypothesis will be the same, okay? So there's no change in the hypothesis versus H1 mu is not equal to 70, right? Now just look at step 2. Just look at step 2. Choose an appropriate test statistic. So here, my test statistic is X bar, right? Here's my test statistic is Z. Later, we will see that we have different types of random variables so that we should just use the appropriate test statistic. Okay, so for now we only have X bar, and equivalently we have Z. Later we will see that we have T random variables, F random variables, chi-square random variables, and so on and so forth. The third step is just establish the critical region using the significance level alpha. Okay, so step three, just find the critical region. Now I should just say, remember okay, so remember how we just proceed. So let me just remember how we just do the find the critical region. So this is the distribution of X bar, right? This is the distribution. Sorry. Let me. Okay. This is the distribution of X bar. So just take, this is what? The region here is 0.025, okay? So what you do is probability that X bar is greater than this value. Let's say this is B, remember, and a similar, I have something here, let's call this A, and the region here is 0.025, okay? And let me also draw this one. Right? So this is mu is equal to 70, right? The probability that X bar is greater than B, this probability is equal to 0.025. Remember, so how do we solve this? How do we solve this? We say, we just convert this to standard normal, so the probability that X bar minus mu of X bar, which is 70, divided by sigma of X bar, which is 0.89, right? So this is sigma of X bar, and this is mu of X bar, greater than B minus, this is 70, right? This is 70. B minus 70 divided by 0.89, that's equal to 0.025, okay? So remember, this is what? This is, so first this is Z, and this is what? So this is the z value, which leaves an area of 0.025 to the right, okay, by definition. So I can just say b minus 70 divided by 0.89 is equal to z sub 0.025, which is also equal to 1.96, okay? And here, your b value, is equal to what? 70, right, plus 1.96 times 0.89. And similarly, you can just show that A is equal to 70 minus 1.96, okay, and times 0.89. So let's open my Excel. Let's open my Excel, okay, and let's recalculate this. So this is equal to 70 plus 1.96 times 0.89, okay, 71.744, which is almost 71.75, okay. So this is 71, sorry, just take this, okay. This is almost 71.75, and this is equal to 868.25, right? Is that true? Yes, that's great. Okay, this is how we just proceed. So let me just take this. So the rejection region is the real numbers minus what? 68.25, 71.25, okay? This is the rejection region. For here, the rejection region is much more simple. That's why we just standardize. Here, we just say the rejection region is real numbers minus 1.96, okay, and 1.96. That's great. Okay, so, right. Now, step four, just calculate, let's see, calculate the test statistic. Observed value under 80. Okay, under 80. Now, what I will calculate is x bar observed. Okay, so what is x bar observed? Remember, that's equal to 71.8. Here, what is z observed? Z observed is equal to x bar observed minus mu of x bar divided by sigma of x bar, which is equal to 71.8 minus 70 divided by 0.89. And recall this was equal to 0.22 and so on and so forth. Right? Now the next step, the final step is decide. Okay, so let me just show it like this. So step 5, just decide or conclude. Now just look at this one. This is this in the critical region, which means, is this here? Well, it's here, right? So you just reject 80 at alpha is equal to 0.05 level, okay? So just look at here, is this 2.022, is it in this region? Well, yes, okay. In fact, this is what we expect because the result should be the same. Reject H0 at alpha is equal to 0.05 level, okay. Well, this is the 5-step procedure of making a hypothesis test. Okay, so I don't see this 5-step procedure in any of the books that I have read. This is something that I just make for myself to understand the hypothesis testing better. And up to now, well, it's people just like this, okay, so students like this. So I just use this in the exam, in your assignments and so on and so forth, this 5-step procedure. So whenever I just ask a question, I just ask, well, just make the hypothesis testing using this 5-step procedure, okay. Now let's see the general settings, the general concepts of hypothesis testing. Well, generally, the alternative hypothesis usually represents a question to be answered or the theory to be tested, okay? So generally what you do is, so for example, if you think that If you think something that should be proven, then you just put it in the alternative hypothesis. That is, if you just think that, well, the height is not equal to 70, what you do is you just put it in the alternative hypothesis. Well, this does not mean too much when we are talking about this type of hypothesis where you have mu is equal to 70 versus h1 mu is not equal to 70. In the future, we will have some hypothesis which is like mu is greater than 70, okay? Then this will have some practical meaning. Then you will try to put your alternative hypothesis in, you will just try to put the thing that you want to prove in the alternative hypothesis, which is something like greater than or smaller than. But in our cases, well, it's not a big deal, okay? Well, the null hypothesis generally is the opposite of H1, and it's the logical complement of H1, okay? And as we said, we will arrive one of the two conclusions. You just reject H0 in favor of H1, okay? Or you just fail to reject. You just fail to reject H0, which means the data that you have is insufficient to say that H0 is not true, okay? So uh, this is not accepting H0, but this is generally what our students say. That's not a big deal. You can say it, but know that, well, this is not statistically true, okay? You cannot say that I just accept H0. Okay, there's a very famous example in your book. So H0 is the defendant is innocent, okay? And H1 is the defendant is guilty, okay? So there is a suspicion of guilt for the defendant, okay, for that guy, but any suspect is considered as innocent, okay, until there is sufficient evidence, okay. So what does this mean? Well, you may have some evidence which shows that the guy is guilty, but the evidence is not, let's say, strong enough, right? If the evidence is not sufficient enough, then you cannot say that, well, the guy is guilty. You assume that I cannot reject the hypothesis that the defendant is innocent, so the guy is just set free, okay? Okay, so failure to reject H0 may not always imply innocence, but shows that the evidence that you have is insufficient to convict the guy. Okay, this is all. In the next um, lecture, we will continue with our next slide, which is the confidence interval for the means.